Starting with Kotlin 1.6.20, we have a new toy to play with, and that new toy is called context receivers. They are a new language feature which gives you an elegant way of constraining functions to a specific context from which they can be called. Today we will figure out exactly what that means. So we're going to refresh what receivers in Kotlin are, and we'll get you set up to try context receivers in your own project, and we'll have a detailed look at how context receivers work and how they can be used. And as we dive in, a small word of advice. Context receivers are currently in the prototype stage, and that's a different thing from being a regular experimental feature in Kotlin. When you enable the context receivers feature for a project, the compiler is going to generate binaries that should not be used in production code. Because context receivers are fresh off the press, they are only available on the JVM. IDE support is also still minimal, so don't expect all the fancy inlay hints, advanced autocomplete, and so on to already be available. At the current stage, you should really only be using context receivers for your toy projects. But context receivers are coming, so what better time to learn about them than right now? And at this point, let me just quickly say a big thank you to everyone who tried the first versions of context receivers already and gave us feedback. Believe it or not, you are helping shape the future of Kotlin. To enable context receiver support in a Kotlin project on 1.6.20 or above, we need to add a compiler flag. In a Gradle project, we can do that by setting Kotlin options.freeCompilerArgs to -x context-receivers. And after a quick re-import, we are actually already ready to get going. Oh, but if IntelliJ for some reason still complains that the feature needs to be explicitly enabled, even after you've just done this, just close and open the project again. You know, you gotta live with some bumps on the road when you're on the cutting edge like this. Okay, we are ready to start our journey. We're going to begin with a recap, like all good stories. Because to understand this new shiny toy called context receivers, we first need to answer the question of what even is a receiver in Kotlin? Well, chances are you actually already know, because you've probably seen and used receiver types in Kotlin in at least two popular use cases, in extension functions and in lambdas with receivers. I want to go through a few examples with you here, because this knowledge will become relevant when we're moving on to understanding context receivers. Let's start by looking at an example for an extension function. Say, for example, you want to extend the functionality of the string class to include a sarcastic mode that just randomly switches capitalization for individual letters. Well, your go-to tool in Kotlin to do that is an extension function. You don't have to focus so much on the implementation of the function, but rather take a look at the overall structure. So for our sarcastic extension function, the receiver is the type after the fun keyword, before the dot. So in this case, that's the string class. Being a receiver type like this has two effects. Firstly, when we have a string variable or a constant like foobar in the main function, we can call the sarcastic extension function as if it was a method on a string object. And secondly, inside the body of the sarcastic function, we can access members of the string object that we're calling the extension function on. We can do that in two ways, either by using the this keyword or just implicitly without using any keywords. That's because the body of our extension function extends the receiver type with some functionality. And as a brief reminder, even though we are adding new functionality to our receiver type, we are not violating encapsulation rules because we don't have access to private members of the receiver type. So while we can't access private members of the receiver type, it allows us to express clearly that our function does something on or to a receiver object, and we don't have to subclass string to add our functionality. All right, let's do one more example where you may have seen receiver types already. And as I said before, the word receiver is even in the name. We are talking about lambdas with receivers. Even if you're not familiar with them, I'm sure you'll spot some similarities in their syntax pretty much right away. For example, we could define a function that prints a transformed greeting. As its transform parameter, it accepts a lambda, which has the receiver type string. That's the greeting that should be transformed. And again, the type before the dot in string.empty parentheses declares the receiver type. And just like an extension function, this has two effects. Firstly, inside the body of print transformed greeting, I can take a variable that has the receiver type, that would be my hello world string, and I can call the transform function on that object. When we look at the call side of our function and I pass a transform block, we can once again access functions from our receiver type either by using this keyword or just implicitly without any keywords. As you can see, I have inlay hints enabled in my IDE, so you can even see that the IDE will tell me that the receiver type of this block is a string. Those actually aren't the only ways of making an object the receiver type for a block of code. But this video isn't about all those fancy features, but there is one more function that's worth pointing out: the with function. The with function takes its argument and turns it into a receiver. A typical use case is when you don't want to repeat yourself multiple times. For example, you may have a logger object which takes care of writing your log files. When you are calling a lot of methods on that same object, you probably don't want to repeat the name of the object a dozen times. So, as an alternative, you can use the with function and turn the logger into a receiver. And just like that, you can call the function names directly. The with function actually gets especially fun when you start nesting with calls. Let's say we have an API class that you want to use to generate the message you're logging. By nesting a call to with, you are introducing a second receiver in the innermost scope. Out here, logger is the receiver type, and in here, logger and API are the receiver types. That means you can call functions from both logger and API without explicitly specifying which object you're calling them on. I know that's quite funky, but it will also become relevant in a little bit. Mark my words. Alright, our minds are refreshed. We know what receivers in Kotlin are, which means we get to unpack our context receivers, our newest shiny toy. On the most basic level, you can use context receivers to express a simple constraint. There are situations where you need something present in the scope, the context, and if it wasn't there, you couldn't do things properly. And that is your context. With context receivers, you can enforce that this something that you need is always present when you call the function. Makes sense, maybe? I know it's very hand-wavy, but let's just go through a small example and introduce context receivers. I'm sure that'll clear it up a little, and you'll get to see what the implications of all of that is. Let's say you have a function that stores a string somewhere. Could be on disk, could be in a database, doesn't matter. We're only pretending at this point. Now, let's add one more requirement. Our function shouldn't just store something on disk, it should also use a logger implementation to keep track of all the write operations. Alright, easy enough, we still have a logger operation from beforehand. That means we can just add it as a parameter to the store function. Alright, that works. But now, when we're in our main function, and we're storing a lot of different things on disk, we always have to pass in the logger manually. There's a lot of repetition going on here, honestly. And I mean, that's not great. We always need a logger to call our store function, but we need to pass it manually all the time. At this point, you might propose that we could create a class that acts as a container for our function, and then give it a logger property. But for illustrative purposes, we're gonna go down a different route. Let's think back to the intro, because this might be the point where we remember that when you call the same function on an object multiple times, the with function can make your code more elegant. Well, doesn't seem like a bad instinct, so we rewrite our code and we wrap the calls to store using the with function. Well, this doesn't work just yet, because we are not calling any functions on the logger. We're only calling functions that take a logger as a parameter. So, at this point, you might actually pull the next magic trick out of your hat. Because we remember that we could just turn store into an extension function on logger. And actually, there's even a refactoring to do this. That refactoring is called convert parameter to receiver. And that works. Well, technically. Because we were so laser focused on making the call side for our store function a little bit cleaner, we ended up modeling the definition of the store function itself. For just a second, forgot how we even got here. You know, pretend you came back from a nice, relaxing vacation, or pretend that you're the new intern who's just seeing this code for the first time. Well, let me ask you, what do you expect a function called logger.store would do? Well, you'd probably expect it to store the logs. But that's completely different from what the function does and what we wanted to express in the first place. So that's clearly no good. So we find ourselves at a crossroads. The function clearly doesn't belong to the logger class, even as an extension. But we also clearly need to have a logger present in its, well, its context. We're getting somewhere. Because remember what I said in the beginning. With contexts, you can express a basic constraint. When you need something present in the scope for things to work properly, that thing is the context. And that sounds exactly like what we need here. We want to have a logger present in the context of our function. So by putting context logger in front of our function definition, we declare exactly that. The store function can only be called if a logger is in scope wherever we call that function. And isn't that already quite the improvement? Our function has returned back to being a top-level function, and the signature now expresses something different than before. It now says, I can be called wherever a logger is present. Hear how that's different from you can call me on a logger? We've just used context receivers to make our code more expressive. And probably the most important part, look at the main function. There are no errors. Inside the with function body, we are now in the context of a logger, so we are allowed to call our new function. If we would try to call the store function just plainly inside main, without first bringing a logger into scope, we'd get an error. Carlin's going to complain that the required context receiver is not found. And when you think about it, that does make sense. We call log in our function body. And for that, we clearly need a logger object. If the scope doesn't provide a logger, how exactly is the function expected to call log? That's why we need to bring a logger into scope before we call the function. If this still feels like an extension function with a twist to you, you're not far off. When you look at an extension function under the hood, it just gets its receiver as an extra parameter. When you're using a context, your function also just gets it as an extra parameter. So you could think of our store function of having an additional anonymous parameter of type logger. In the body of our function, adding context gives us access to this context receiver type. It's almost as if we now have a this to access functions and properties from our logger object inside the block. That's the magic that allows us to call public functions and properties from the context object, like the log function. What makes context receivers special is that, unlike extension functions, we are not limited to having only one context receiver. We can have an arbitrary number of them. Let's say our requirements change, and additionally to logging, we now also need to send a notification through a different system. We are keeping it simple, so I'm just going to have my notification sender class with a send function defined here. And to give myself a little bit of space, I'm also going to use the expression body syntax for our logger implementation. Now, if we want to send a notification from our store function, we can just add notification sender as an additional context receiver. And just like that, we can call the methods and properties in the function body. All right, now expectedly, this turns our main function red and squiggly because our function now needs a notification sender to be present in the context. But it's a quick fix. We can just introduce another nested with clause that brings a notification sender instance into scope. I told you nested with statements would become relevant again. In the future, maybe we'll also get an even more elegant way to introduce multiple receivers to a scope all at once, but for now, this is the way to go. Now, if your initial hunch is that this isn't ideal yet, you are spot on. There are still a few issues that we do need to address. Here's one that's probably the most glaring. When you add a context that's similar to doing a local star import, you pull all the symbols of the context receivers into scope. You may have noticed that we silently moved from calling logger.log to just calling log. We are also calling send just as a freestanding function because it's just accessible to us now in this scope. At its most harmless, this can just get a little confusing. So when I write a line that uses the name property, for example, it's not really all that clear where name is actually coming from. In case you were wondering, it's coming from the constructor of logger. But things get real problematic when the person building Notification Sender now also introduces a name property. Because would you look at that? There's an overload resolution ambiguity. Just like that, by modifying two classes that should not know anything about each other, we've introduced a resolution ambiguity. Now, of course, context receivers come with a mechanism to remove this ambiguity, using labeled this statements. These labeled this statements allow us to really hone in on which context receiver we actually mean. But that doesn't really save us from things breaking further down the line. Say, for example, some domain expert comes along and notices that the correct terminology for the notification system you're using is also log. Collisions can just happen. And great, now we're starting to sprinkle labeled this statements all inside the body of the function. That's not exactly amazing. But at the very least, we have arrived at an important mantra to remember for context. Don't do what we just did. Don't just wildly inject business objects. You usually need to design new types from scratch to use them as context parameters. Why? Because contexts introduce additional requirements on naming for their members and extensions. There might be cases where using a trivial object as a context receiver is okay, but you have seen the risks now. So let's follow our new mantra. Designing a type for our context parameter sounds fancy, but in reality just means that we define an interface or class specific to the context. Our logger context interface then just gets logger as one of its properties, and our notification context is pretty much the same. By specifying that our context is now logger context and notification context, we've introduced the same kind of indirection that we had at the very beginning, when logger was just a simple parameter for the function. We've also stopped polluting the namespace inside the store function, because now it's clear where functions come from without having to sprinkle labeled this keywords all over the place. And if we ever decide to add additional functions to Notification Sender or to Logger, we won't have to worry about collisions or anything like that. The two implementations don't have to know about each other, just as we initially intended. This looks much better, and is incidentally also how you should do it. Now, to make our program work again, we need to make a couple smaller changes still, and instantiate the interfaces in our main function. You might do that by creating a class that implements the interface, but I'm just using an object expression since that achieves the exact same goal. Now, at some point, we might obviously come back to our code and maybe refactor it a little bit. For example, we might be extracting other functions. And that works just as you would expect it to. Where before we called logger.log directly, there's nothing from stopping us from creating a new function, log storage events, which also has a logger context as a context receiver, and calling this function from our original store function just as well. Just so that you've also seen a context function called without the with function. Because remember, inside the function body of store, logger context is already in scope. That means if a function you are calling inside that body requires a logger context itself, it will just pick up on the surrounding context. Now, granted, this example looks longer and includes more concepts than what we started out with, but keep in mind that we've stripped this application to the very bare essentials. As you introduce context receivers in more complicated applications, these benefits hopefully become even more clear. In this case, I chose to create two independent context objects to show off the fact that we can have more than one context, but it's perfectly permissible to combine, for example, Notification Sender and Logger in a storage context, if that makes sense in your domain. These don't always have to be single property interfaces. Now, before we move on, let's just address one more thing. A lot of this might still feel like extension functions when you first encounter context receivers, but the calling conventions are quite different. Now that we have two contexts, this might sound almost trivial, but just for clarity, you can't call functions marked with a context receiver on objects that have the type of the context receiver. That means you're never going to see code that looks like this. It really doesn't matter whether all the other contexts are in scope. And I hope that by now it makes sense why that is the case. You aren't calling functions on a context, you're calling functions in the presence of a context. If you want to call something on an object, that's what we have extension functions for, and those are not going anywhere. Sweet, at this point we've established our basic knowledge of context receivers. So, to recap, context receivers give you an elegant way of constraining functions to which context they can be called from, without relying on inheritance. So, since this was our first time really having a look at context, I wanted to keep everything simple. That's why store was also just a file level function so far. But in fact, nothing is stopping us from stuffing that function into a class, like you probably would at some point anyway, as your application grows in complexity. You can still instantiate a class like this as you usually would, but when the time comes and you want to call the store function, you still need to bring logger context and notification context into scope. But it's not just functions that we can mark as requiring a context. We can also put the context declaration before the class keyword. And now this changes the meaning. This means that the class can only be constructed when the surrounding scope provides logger and notification contexts. If you think about it, in this case, using context receivers almost achieves something similar to dependency injection, because to construct the object, you need both a logger and a notification context object, and inside the repository, you can access the logger and notification sender properties. To make this code work again, all we need to do is move the constructor call to repository inside the bodies of our with functions so that notification and logger context are in scope. And then we can just call store because the repository object already knows its contexts. And that's not even the end of it. You can also annotate properties with a context, for example. Or if you have a lambda parameter for a function, you can enforce a context for that as well. As I've said, it's a new toy, so I'll leave you some of the bits and pieces to play with and get an intuition for. But still, with so much versatility, so many ways to use contexts, you might still be a bit puzzled when it's a good idea to actually use a context receiver. Thankfully, the folks designing the language feature provide some guidance on that topic. Context receivers shall be used to provide additional ubiquitous context for actions. As a litmus test, ask yourself if that information might have been provided via a global top-level scope in a similar application with a smaller architecture. If the answer is yes, then it might be a good idea to provide it via a context receiver. Well, that's useful to know. Let's see if this quick test actually works for our example code. Well, if my application had a simple architecture with very few moving parts, I would probably just have a global logger and notification sender instance, just hard-coded. So we can conclude context receivers are a good fit for such a situation. Again, the use case for context coincides with the name. Only use contexts when you're doing operations in the context of something. If you're doing something on or to an object, and you find yourself reaching for a context, you should pause for a moment and see whether extension functions are a better fit. Now, funnily enough, you can combine a lot of clever approaches to get behavior quite similar to that of context receivers if you have full control over all the classes in your system. But when that's not the case, you might find yourself running out of receiver types if you don't have access to context receivers, which ultimately just means that you wouldn't be able to express yourself the way you want to. Let me show you what I mean. Let's assume we're building some kind of bookkeeping system that keeps track of bookings in multiple different currencies. To support that use case, we are given euro and dollar classes as well as an exchange rate provider. I hope my currency data classes don't spark too much controversy. Though this video would probably get more comments if I used floats. Anyway, we're just in a demo. So for this example, let's assume that we can't touch these classes. There's a number of reasons why that could be. Because they come from a third-party library, maybe they're managed by a different team, or they're maintained by one random person in Nebraska. Let's say you want to write a function that calculates the monthly revenue in euros. To do that, it first gets the US and EU revenues from somewhere. I am just going to hardcode them, and then it adds them together. Obviously, US revenue and EU revenue have differing types, so to make the addition, in the last line here possible, we need to override the plus operator between euro and dollar objects. But as we write the implementation, we realize that we need to access the exchange rate provider inside to get to the dollar to euro conversion. And now we're in a pickle. We can't put it as the receiver of the extension because we need the euro type for the left side of our operator, We can't put it as a parameter because plus is a binary operator. It only takes 2 values. So, what can we do? Well, you probably guessed it. We're gonna use a context receiver. First, we want to keep everything clean, so we create an exchange rate context interface, and that just wraps the exchange rate provider. As the next step, we add this exchange rate context to our operator function, which makes the operator only callable when an exchange rate context is in scope. And just like that, we have upgraded our binary operator to take 2 receivers. Euro, the type we extended, and exchange rate context, where we use the dollar to euro property to do our conversion. And by the way, as you can see again, it's not just functions that we can bring in using a context, properties work just the same. We've done this before. At this point, we're already used to it. The problem bubbles up to our monthly revenue function. This error message shouldn't be too surprising since we've just added the constraint that euros and dollars can only be added if an exchange rate provider is in scope. And that checks out. Without an exchange rate, we can't really convert the values. So let's once more go over our options. Well, first, we've already seen it. We could instantiate an exchange rate provider, wrap our return expression in a with statement, and then bring that exchange rate provider into scope. We've seen all of this already. But we also have other alternatives. We could accept the exchange rate context as a parameter for calculating our monthly revenue, and then use that in a with statement. Or, as you've probably already guessed it, we could just define our monthly revenue function to only be callable in the context of an exchange rate provider. And honestly, I think this solution is my favorite, because it's rather elegant. Especially it's nice that the body is now nice and clean again. Let's make sure that we did the right thing and repeat the quick test from before. Remember, ask yourself if that information might have been provided in a global top-level scope in a smaller application with a simpler architecture. Well, if I had a very small app, I would probably just have a singleton or global instance of the exchange rate provider. That seems like a good fit for using context receivers again. So with that, we have contextified our little exchange rate app. And hopefully you now have a bit of a deeper understanding of how context receivers can help you when you're running out of receivers or extending classes you don't have control over. I think we've covered most of the mechanics of context receivers as well as some of the basic use cases. But there's actually quite a bit more you can do with them. So before we call it a day, I want to briefly introduce a few other use cases. And I'm sure a lot of you folks in the community will also find your own. The first case are nicer transaction APIs. Remember how we said that context-specific functions can't be called on objects that have the type of the context receiver? Well, if you're building an API where you're expecting certain methods to only be called inside a transaction block, for example, like my connect function here, you can ensure that people don't just manually construct the transaction scope and call the transaction function like that through the power of contexts. When you want to build DSLs for existing libraries, context receivers also help you to be more flexible in the way you structure your DSLs. One example is this JSON DSL that builds on top of the JSON object class from JSON, which we obviously don't control. And still, we can use binary functions such as infix functions in the context of a JSON object. Another example that might resonate with you Android developers out there is the work with different types of measurements for pixels. Very briefly explained, Android differentiates between DP, that's density independent pixels, and PX, actual physical pixels on the device. So right now the conversion functions are actually defined inside the density interface, even though they extend the DP class. Again, we ask ourselves, is this really the right place for those functions to live? Should density even have to know about the concept of a device-independent pixel? With context, this implementation could be decoupled and simply defined as an extension function on DP that can only be called when the context provides an instance of the density interface. And lastly, context receivers provide an interesting new way to kind of cascade dependencies in a hierarchy. When we have a logger context and a repository class that instantiates a file system class that also requires a logger context, that child object can automatically receive the logger context from the parent object that instantiated it. But of course, as you play around with it, you'll find many more ways of using context receivers. I'm sure of it. I can't wait to see what you'll be coming up with. I think at this point you're pretty much ready for your own experiments. To sum up, Context receivers give you an elegant way of constraining functions, properties, and constructors to which context they can be called from. It allows for composing context without requiring inheritance, and you bring it into scope or in the context by using Kotlin's scope functions. The use case coincides with the name. Only use contexts when you're doing operations in the context of something. If you're doing something on or to an object and you find yourself reaching for the context, pause for a moment, see whether an extension function is a better fit. It doesn't matter whether it's context-specific functions, properties, or whole classes. When the correct context is in scope, you can access or instantiate them. With context receivers, you are adding additional, ubiquitous context for actions. The kind of stuff that you would keep in a global, top-level variable if your application was real simple. Give context receivers a try, experiment with them, and give us some feedback on the UTrack issue tracker, but maybe don't overdo it. As with a lot of features, I predict there will be a honeymoon phase where we'll all use our new shiny toy everywhere until we figure out the sweet spot. If you want to dive even deeper into the current state of context receivers, do check out the official proposal docs that we keep in the Kotlin Keep repository. Simon from the Arrow team has actually also written a nice article on context receivers in practice with Arrow, where he talks about how context receivers may help them clean up function signatures and implement so-called effect handlers. Go read his blog post if you're a fan of Arrow and want to see how things are going to influence that library. Context receivers actually aren't the only thing that came out with Kotlin 1.6.20. There's things like definitely nullable types, parallel compilation, Kotlin native multi-platform mobile, and Kotlin.js continue evolving, and much more. Anton has all the details in the What's New in Kotlin 1.6.20 video, so maybe check that out next if you haven't. I'm off to experimenting a bit more with contextual receivers myself now. Take care.